Hello everybody, this is Ms. Bushra. Welcome to the math class. Today we'll be talking about synthetic division, um, part 2. So last time we explained how to apply synthetic division on polynomial functions. And today we'll be talking to you about synthetic substitution actually. So what are all the uses of synthetic division? Synthetic substitution is close to synthetic division, but it has other uses actually. Now, let fx be 2x squared plus x minus 3. So the question here is evaluate fx for x is equal to negative 3. So if we go the old way, let's use fx or the plug-in chug way. So fx for x is equal to negative 3. So f negative 3. If you go the old way, you get, because the question says evaluate fx for x is equal to negative 3. So you'll be plugging in a negative 3. Whenever you have x, you need to plug x by negative 3. So I'll go with 2x squared, which is negative 3, plus x minus 3. So if I replace with negative 3, then I will calculate. So I have negative 3 squared is 9, 9 times 2 is 18, plus negative 3 minus 3, and minus 3. So I will get 18 minus 6, which is equal to 12. So plugging in negative 3 in fx will give us negative or 12. Now let's see the other way using the synthetic substitution. So what do is we kind of go through the same process as we are having synthetic division. So I'll take the factors of your fx here, every term of fx. So I take the factors, I'll be writing the factors again. So I have 2, I have 1, and I have negative 3 as a constant. Then I go through the same way as I'm doing a synthetic division. So I'm plugging with negative 3, so I'll be taking here negative 3, and I'll pursue the same process. 2 and 2 times negative 3 is negative 6. 1 plus negative 6 is equal to negative 5. Negative 5 times negative 3 is equal to 15, and 15 plus minus 3 is equal to 12. You see here 12 is the same answer that I found as I was plugging in. So using the same way, or synthetic substitution would give you the same answer, but maybe synthetic substitution is better and you go way faster, especially if you have polynomial functions order 4 and order 3 and order 5, order 6, and so on. So let's see another example. Here there is another example about here find zeros for a cubic polynomial function x3 minus 4 x2 plus 5x minus 2. So it means solve bx is equal to 0. So you need to solve x3 minus 4x2 plus 5x minus 2 is equal to 0. So you need to find out the zeros or the roots for this polynomial function. So the things that comes to my head here is to apply the rational roots theorem. So we need to find out what are the here if you talking about p and q, and we are talking about factors of number of negative 2 here and factors of 1 here, that comes by this term here, coefficient of x cubed, which is equal to 1. So 1 times. So possible zeros are here plus minus 2 plus minus 1 over plus minus 1. So possible zeros are plus minus 1 and plus minus 2. So what do we have to plug in are these four plus minus 1, plus minus 2, four values of x to try to find out which one of them or which ones of them are real zeros. So what I invite you to do is to use synthetic substitution to find a way which ones are the real zeros. So how we do that is, again, I would take the coefficient that I have here of each term of my polynomial function, all right, and I make sure to go through all the degrees here, 3, degree 3, 2, 1, and degree 0 in order. So I would take here the coefficient of these terms here, then I write them back as I'm going to do a synthetic division. So I have 1, negative 4, then I have 5, and I have negative 2. Then I will go through my synthetic division, and I have 1 and plus 1. I have negative 1 here as possible zeros. I have plus 1, negative 1. I have plus 2 and negative 2. So I'm going to go with plus 1 as a start, all right, to check which one of them is a real zero. How do we know if it's a real zero or not? We will see. So I drop down the 1. 1 times 1 is equal to 1. Negative 4 plus 1 is equal to negative 3. Negative 3 times 1 is equal to negative 3. 5 plus negative 3 is equal to 2. 2 times 1 is equal to 2. And negative 2 plus 2 is equal to 0. Actually, that's exactly how do we know that the number that you're checking your polynomial function for, the root, the possible root, this one is a root for your polynomial function. Whenever you finish your division and you find out that your leftover is equal to 0, there is no remainder, so this value here is equal to 0. If you find that this value here is equal to 0, that means that this value of x that you are trying to check your synthetic division for is a real zero for px. That means if you plug in p, if you calculate p of it 1, it will give you 0. If you use it, if you try to use plug in check the old way, you will find out that p of 1 is equal to 0. That means that 1 is a root of px. Now what I want to do is I want to go and check for the other values here. I want to check for the rest of the values. So here you are. Okay, so I have p of x here. Then we checked for x is equal to 1, and we found that it was a real 0. Now let's check for x is equal to negative 1. So why not? Now I will again take all the coefficient of the terms that I have, and I will order them. So I have 1, I have negative 4, and I have 5, and I have negative 2. Then I'm trying to check for larger a little bit. So I'm trying to check this time for negative 1. So I drop down the 1, and outside of the borders I just have to multiply, and if I go inside the borders, then I need to add vertically the number that I have. So 1 times negative 1 is equal to negative 1. Negative 4 plus negative 1 is equal to negative 5. Negative 5 times negative 1 is equal to 5. 5 plus 5 is equal to 10. 10 times negative 1 is equal to negative 10, and negative 2 plus negative 10 is equal to negative 12, and this time this is not equal to 0. You have negative 12, so you would say that x is equal to negative 1 is not a real 0, is not a root of px. All right, so let's try for x is equal to 2. All right, so again, I'll take the coefficient 1. All right, I'll take 1, negative 4, I'll take 5, and negative 2. Then I'll plug in here 2, then I'll drop the 1, and I have 1 times 2 is equal to 2. Minus 4 plus 2 is equal to negative 2. Negative 2 times 2 is equal to 4. 4 plus, hold on, negative 2 times 2 is equal to negative 4, and negative 4 plus 5 is equal to 1, and 1 times 2 is equal to 2, then negative 2 plus 2 is equal to 0. So you can see that you have here a remainder is 0, there is no leftover, so remainder is equal to 0. This is your remainder in your division. So I would say that 2x is equal to 2 is a root of px. So we checked for 1 and 2, negative 1, and let's check for negative 2. So again, okay, so again, I'll check for negative 2. What I have to do is I'll take the coefficient 1, negative 4, 5, and negative 2. Okay, then go with negative 2. So I drop the 1 here. 1 times negative 2 is equal to negative 2. Negative 2 plus negative 4 is equal to negative 6. Negative 6 times negative 2 is equal to 12. 12 times 5, 12 plus added to 5, sorry, is equal to 17. 17 times negative 2 is equal to negative 34, and negative 34 plus negative 2 is equal to negative 36. You can see that this value here is not equal to 0. So I can say that x is equal to negative 2 is not a root of px. So as you see, if you try to here plug in, if you try to plug in x for x is equal to negative 2 through px, you would have to go through plug and chug the old way and calculate and deal with the cubics and squares and negative and positive signs. And in my opinion, using synthetic substitution is faster and safer. So this was the other use of synthetic division with polynomials. I hope that you enjoyed the video, and see you next time.